Theory of measurement and control. Measurement is the act of using a device or instrument to determine a physical quantity. Control, meanwhile, is the act of regulating it or the output of a system having both inputs and outputs. These theoretical concepts are fundamental to an understanding of computer-controlled embedded systems. Signal processing. 1. Analog versus digital signal. Humans receive information about their surroundings in various forms from sensory organs, such as the eyes and ears. Naturally occurring phenomena are continuous in nature. Continuous information, such as light and sound, is referred to analog signal. Discrete information, information which is countable, is called digital signal. Two. Signal conversion. Signal processing is the process of converting a signal, such as audio, light or electromagnetism, into a different type of signal. Signal processing is broadly divided into analog signal processing and digital signal processing. In a controlled system, the inputs and outputs involve analog signals, such as position, pressure, temperature and voltage. This requires analog to digital signal conversion at the input stage, and digital to analog signal conversion at the output stage. A. Analog to digital conversion. The process of converting analog signal to digital signal is called analog to digital conversion. As the diagram below shows, analog to digital conversion involves sampling the value of the analog signal at fixed intervals and expressing the value in binary form. Clearly, analog signal that fluctuates strongly will require more frequent sampling at shorter intervals. The required sampling interval is governed by the extent of change in the analog signal. The general rule is that a sampling frequency of twice the maximum frequency present in the analog signal will be sufficient to enable faithful reproduction of the original analog signal from the digital signal. B. Digital to analog conversion. Digital to analog conversion is simply the opposite of analog to digital conversion. In other words, the process of converting digital signal into analog signal. Three. Filters. A filter is a circuit that allows only frequencies within a designated range to pass through by removing all other frequencies. Filters are used in analog to digital conversion to suppress the maximum frequencies, particularly noise, and in digital to analog conversion to smooth the analog signal. Theory of control. In actual system control performed by a process computer, an operating system designed for real-time control is used to control the subject, known as the real-time OS. One. Mechanism of control. A. Feedback control. The aim of feedback control is to maintain continuous quantities, such as displacement and speed, at fixed values while approximating them as closely as possible to the target values. The term feedback denotes a system configuration in which the system output influences the system input and/or operations. B. Feed-forward control. In feedback control, the adjustment is made after the output signal has been generated. Thus, when a disturbance phenomenon occurs, the controlling operation does not take place until after the disturbance has exerted its impact on the system. In feed-forward control, however, the adjustment is made before the disturbance phenomenon is able to impact on the system. Whereas feedback control represents a closed loop with a repeating signal flow, feed-forward control does not involve repetition. Feed-forward control is therefore known as open loop. Despite the theoretical advantages of feed-forward control, it is not usually sufficient as a control system in itself. For this reason, feed-forward control is generally used in conjunction with feedback control. Two. Response characteristics. In certain situations, the application of an external force or change to a system will elicit a known response. In other words, there is a fixed relationship between input and output. This relationship is termed the response characteristics. Some examples of response characteristics are: a force applied to a machine in a given location will produce a change in a specific location. A voltage applied to the terminal of an electric circuit will generate a voltage at another terminal. 3. Control stability. Control stability is the ability of a system to ensure consistent output under the influence of a given form of energy, such as physical force, heat, or electrical power. The ability of a control system to provide the necessary control stability is a key consideration at the design stage.